So if everything goes according to plan, today we are finally going to get the Junkyard 8.1 quote-unquote budget bulletproof build back together, or at the very least, the short block put back together so we can get the engine back into the truck and the truck back to the track, and hopefully, if everything goes according to plan, this is like a really lofty goal, but hopefully we can run a 9-second quarter-mile pass with this truck. That's a really big goal, but who knows? We've been 1090s. That's a pretty big step. Anyway, we're back in town. All the parts are cleaned up. We have the crank polished. We have the block really, well, not really cleaned as good as I can get it right here in my shop with the tools that I have. So first thing we're gonna do, throw some bearings in it. We're gonna verify clearances because you gotta do things the right way. And then if everything checks out, put the crank in the block for good, bolt it down with new fasteners, and we'll be on our way. So let's jump right in. Before we get started on today's action, I wanted to take a second and talk to you about the sponsor of this video, which is Solder Stick. Now, if you any sort of wiring on your car or truck or boat or inside your house, or basically any sort of wiring that needs to join two wires together, you definitely need to check out Solder Stick. Now, one of my favorite products that they make is this kit right here, which is for heat shrink butt connectors. There's 500 pieces in it, and they go from 10 gauge all the way up, or all the way down, I should say, to 26 gauge. And what makes these so special is basically there's a little band of solder encased in some heat shrink tubes. So basically, once you join your two wires together with the stripped ends, you apply a little bit of heat, and that solder is going to flow in between the two wires, and it's going to make the connection. And the heat shrink, of course, is going to make sure it's weatherproof. So one and done, no crimping required. Just put a little heat on there, whether it's from a lighter or from a campfire or a torch or a heat gun, whatever you have. If it's warm enough to melt that heat shrink in the solder, it's going to make a connection, and it's weather tight, and it's going to last for a very long time. Solder Stick has a special going on right now. If you use the code LT20, you can save 20% off your order, whether that's the heat shrink butt connectors like this or their heat shrink ring terminals. I've got both of them here because as we do wiring, we use pretty much all the stuff. So check out Solder Stick and use the code LT20. All right, so future me talking about work that we did in the past. I did have a little bit of an issue. I put all the main caps on with the bearings in place, torqued it all down, used the micrometer to measure the journals on the crankshaft, and then used the dial bore gauge to measure the clearance of the bearings. Every engine has a particular range of clearance that you want for oil. This one measured in anywhere from about 23 to 26 tenths, so 0.0026 or so of an inch, which is a little bit tight for what we're doing with our power level and stuff like that. I want it to be just a little bit looser. So I put the brakes on that for a little while. The new bearings actually just came in. These are both Clevite H series bearings. The ones that we started out with were the stock size. Just a tiny bit too tight, so we ordered a set of X bearings that'll give us a thousandths of an inch, one thousandths of an inch more clearance, so 0.001 inch greater in diameter. We're actually going to do a half set because we only need about 5/10ths of a thousandths. Yeah, tenths of a thousandths of an inch. Anyway, so we got a little bit bigger bearings. They finally showed up, so now we should have everything that we need to finally assemble this for good. So I'm going to put the new bearings in. I'll check the thrust clearance on the crankshaft. Also, I did measure the rods, and those with the stock size bearing, they measured in perfect right where we want them. So I just needed an half X set on the mains. So let's continue on and get the short block put together. All right, so we're going to be putting the thinner X bearing on the block side. The thicker standard bearing is going to go on the cap because that's the load side, and because that's what Pat told me to do. So I'm going to do it. Now, I'm kind of debating showing you guys this, but these are standard big block Chevy bearings, and this is an 8.1 block. The only difference is this little groove for the tang on the block side of the first four is a little bit narrower than on a standard big block Chevy. So some guys will just grind the tang off. What I did is I just kind of narrowed it up so it still is on there. Definitely not something that you want to do on a new set of bearings, but to get Clevite H-Series X bearings for an 8.1, they're back ordered like forever, so this is the next best thing. And if you're very, very careful, you can do it without damaging the bearing. All right, we had 28 before, and this should open it up with a half X to about 32, if my math is right. $34. We got all the clearances checked, and this is a process that I highly, highly recommend if you're going to be putting together any sort of an engine. I don't care if it's a Briggs & Stratton or a 10,000 horsepower top fuel engine, you always got to measure the clearances. Most of the time they're probably going to be okay, but in my case, the stock bearings were just a little bit on the tight side. Would it have caused me any problems? Maybe, maybe not. That's debatable, but I would much rather, number one, know what the clearances are exactly, and number two, be able to adjust them to suit what I want. And for this application, with the power level that we're making, I wanted it to be a little bit looser. We have a stock cast crankshaft. This is not a forged 8.1 crank. There's a chance it may flex and move around a little bit as we're making power, because before this thing made 1,100 pound-feet of torque at the tire. So stuff could be moving around a little bit, which is why I'd rather have the little bit extra clearance. So that's my little sermon for the day. Always do stuff, quote unquote, the right way. Plastic gauge is nice. This is a little bit nicer. These are from MSC, but you can also get them from Amazon, similar stuff. So I'll put some links below. And this is a useful tool. It goes from 2 to 6 inches. We can measure rods, we can measure mains. You know, we can even measure the cylinder bores for roundness or for, you know, it's a very useful tool. Like I said, if you're going to be building engines, you probably ought to have something like that. Even if the machine shop does it, trust but verify. That's, again, that's my sermon for the day. Anyway, I'm happy with where the clearances are, so now we're going to start putting this thing together. The only thing I have left to verify is the end plate or the thrust of the crank. So we'll check that. As far as I'm concerned, if that checks out, the crankshaft can go in for good till it breaks next year. All right, so the first major step is done. We got the crankshaft in, fully torqued to spec. Next thing that we got to do is put the rings back on the pistons and then put the pistons back into the crank. And we've already gapped the rings and we already checked the clearance. Now, you guys don't know this, but we're actually in a little bit of a race to see who can get an 8.1 built the quickest, because I have mine and Nick, he actually has an 8.1 that he's putting together, believe it or not, for a truck almost exactly like, do you have it today? We'll show up. Almost exactly like mine. So Nick, as you can tell, his engine's a little bit further along, but tell everybody real quick just what you're putting together and what this engine is.
So it's not a junkyard engine. It's out of a FedEx truck that I've gone through, added bigger pistons. I think I bored it 30 over. It's got the deeper cut for the relief of the valves. It's got the bigger valve springs with the 7-to-1 rockers, comp cams in there. The camshaft is a custom camshaft grind. I forget the numbers on it.
Top secret, right?
Yeah, top secret. I'm not allowed to release those. That's secret information. You know, only certain people are allowed to see those numbers. I forgot about that.
So what are your power goals for this? Like when it's all said and done, and because you're doing 2 stages.
Correct. So stage 1 is going to be NA. I'm thinking it should be somewhere around 500-600-ish maybe. That's probably on the, you know, I'm hoping end, but probably not. I'm going to run an NA for probably a year, and then after that it's going to go turbo, that I want to be 12 to 1500 horsepower. So 12 to 1500 horsepower and about similar in foot-pounds of torque. So
well, there you have it, guys. This is a pretty cool engine, and it's a pretty cool truck that it's going in, but he's got a bit of a head start on me, so we got to get back to work. Okay, so the rotating assembly is put back in the block 100%, everything is torqued down and ready to go. And the only question is, what's the failure point going to be? Because if you remember, the whole reason why we are embarking upon this exercise is really to see how strong the stock 8.1 rotating assembly is. Pistons, rods, crankshaft. I thought about replacing this stuff and upgrading it, but I want to know what it can hold up to. So anyway, that's kind of why we're doing what we're doing. But there's a few other changes that I want to make other than opening up the ring gap and just sealing the leaks, and that's a different camshaft. So that's going to go in next. This is the guy right here. Comp cams, the part number right there. Now this is actually a Gen 6 big block Chevy crankshaft, or not a crank, it's a camshaft. So it has a different firing order than the 8.1, so that'll require a few wiring changes and stuff, but not a big deal because effectively the camshaft is the same exact thing, minus the firing order. So that's the cam. It has a max of 510 lift. We're keeping that nice and safe for the stock pistons because these valve reliefs aren't all that big. And then, let's see, I forget what this was, but 224, 230 at 50 thousandths lift, and it's on a 113 lobe separation angle. So a little bit bigger camshaft than stock. Yeah, can't speak today, but it's definitely a little bit on the mild side. I don't want to make this thing spin to 7,500 RPM because it's just not meant to do that. But this will help maybe spin the motor to like 6,000 or so and shift that power band up a little bit. And of course the valves, which we'll get to, or valve springs, we'll get to at a later date, that'll help control the valve train at a higher RPM because we want to make more power at more RPM and make the truck go faster. Anyway, all that aside, that's the cam. We just talked about that. JP Performance double roller timing chain specific for the 8.1. It has the groove for the camshaft position sensor. ARP bolts, these are 5/16 because this is a traditional big block Chevy, not the metric cam bolt that the old one was down there. So anyway, get the cam put in. We will check the position. We'll degree the cam, quote unquote. So let's carry on. All right, so this is one of my favorite parts of the build because all of the quote unquote technical work, or most of it, is done. We have our bearing clearances checked, we have a ring gap set, we have the cam degreed. Basically the bottom end, or the rotating assembly of this engine, is ready to go. The only thing I'm gonna do right now, pull the cam bolts out, just put some Loctite in there and torque them to spec because I didn't know if we were gonna have to change the cam timing around, but I checked it 3 or 4 times. It came to a 113 3/4 of a degree of intake center line, which means it's technically 3/4 of a degree retarded, which retarding the cam timing will technically shift the power band a little bit higher and make a tiny bit less torque, but 3/4 of a degree is pretty much gonna amount to nothing. So anyway, as far as I'm concerned, cam is right where I want it to be. And now, well, really, next thing I want to do is just kind of get the bottom end 100% buttoned up. So, like I said, we'll get these torqued into place, put timing cover on with fresh gaskets, oil pump. We've got a M77HV, I think, Melling oil pump, high volume to help with a little bit of those bearing clearances where we opened everything up. Other than that, we got the windage tray, just a few other odds and ends. So let's get this bottom end together. All right, so the work week is winding down, Friday afternoon for me, and I have made some good progress on this engine finally. Very happy with the point that we got to. It's all bagged up right now, but we have the short block put back together. Pistons, rods, we've got new bearings, everything is cleaned up, gapped the rings, and we're just gonna push this thing, hopefully not to the breaking point, because I don't really want to scatter it, but I just want it to run a little better than it did before, and kind of see what a stock bottom end 8.1 is going to do. I started working on the valve train. I'll show you that in detail in an upcoming video, but I'm waiting on one more part just to make sure we get these valve springs installed at the correct height to work with our hydraulic roller lifters. But other than that, like I said, I'm real happy. We'll show you all this. I had to buy one of these cool nifty tools, which I'm really excited about. So we're mixing and matching parts, just trying to make sure the valve springs stack up how they should. Anyway, thank you guys for watching. I appreciate it. Sorry for the long extended break, but we're back at it, and I am hustling, trying to get this truck put back together because, I mean, it's August pretty much. I mean, it's the 20th of July for me now, but let's call it August. Summer is going by quickly, and I want to get some miles on the ugly truck. Excuse me. I want to do some more burnouts, and I want to get this engine back in. A couple more things I'm going to do. I do want to paint the engine, which you'll see that. It's going to be low-key, just kind of like satin black. But I'm going to get all of my turbo hot side Cerakoted. I want that kind of satin black-ish, maybe it's kind of gray. So I spent a bunch of unnecessary time this morning just kind of grinding off all the old casting flash for the manifolds. This is a turbo kit that I built in late 2020. I was actually unsure about how well this was going to last because we welded some mild steel pipe, Schedule 40 weld pipe, to the stock manifolds, and I was positive that over time this joint here would crack. Surprisingly, with all the heat cycles that we've put this setup through, the turbo kit is rocking and rolling. So I did one more addition. Today I added in this back pressure port so I can measure turbo back pressure when we get the Holly running on this thing. So anyway, that's kind of where we're at. We're going to drop those off in the morning to Cerakote. I'll do a little bit of painting or powder coating possibly on the polished aluminum charge pipe. So it's going to be real low key under the hood, but we're still going to kind of keep it the vibe of the ugly truck. So thanks for watching, guys. Come back soon.